Good. I'm Timo Hämäläinen, and I'm sharing this presentation slot with Esko Pekkarinen, who is the key architect of this Kactus2 open source IP-XACT tool. So Esko will give a demo and show real code. I will show only business graphics to you. So just to get introduced to what is IP-XACT. Okay, but let's start from a brief introduction of who we are. I'm currently running two open source research projects. The one is what we are talking today, Kactus2, and that's belonging to the soft design methods and tools research area. And then we have another quite big effort on implementing open source HEVC encoder, as I'm named Quasar. But let's come back to some 20 years. Here's my PhD thesis topic. It was an FPGA and DSP-based accelerator card for neural network and genetic algorithm execution. So I don't know whether I can say in this audience that there is no need for RISC processors because we have this brain kind of computation in the future in the next 20 years. Years later we experimented with massively parallel systems on FPGAs. We no longer were implementing our own boards but used development boards from the manufacturers, vendors. And here's one example where we had 10 nice processors and then some accelerator blocks for DCT motion estimation and other video encoding stuff, and we connected 3 ports together, so we get something like 66 IP blocks all together. And that was experimenting the scalability of the video encoder, but also scalability of the interconnection network that we developed for that purpose. So this year we have been implementing Quasar HEVC encoder on TeraSiC weak platform, including Cyclone 5 chip, and there we also put together quite many things in development flow, starting from the C code from Quasar, created system C models, first untimed, separated communication and computation, then had timed transaction level modeling, and finally we ended up with high-level synthesis so that we tried to make the design without writing any line of VHDL available code, just using high-level synthesis. And we presented the paper on PSD 2015. We have an IP-XACT model of that implementation. Here's the block diagram, PowerPoint block diagram of that. And we implemented the green shaded area here using the high-level synthesis, and the rest basically was taken from the libraries that we either coming directly from TeraSiC's example designs or then what we had already in our repositories. But we have been experimenting with the design flow development quite a long time, starting around year 2000, using SDL language and telelogic tool for generating code out of the graphical models, and we used the custom wireless LAN protocol stack implemented on that. And at that time, yes, we get it working, but the code that we generated was quite badly loaded, and it required lots of memory and was not that efficient. And later we started 2 big projects about UML as a design capture for soft designs, and we had 2 goals basically. One was that we wanted to find a way how software and hardware things would speak the same language that was coming from the industry. And then another one was that when we are performing modeling, we should use the model itself as part of the implementation. So if you are making a plastic miniature module of an airplane and then you have wind tunnel test, then everybody understands that this model itself is not going to be used as part of the implementation. But when you are using the same idea in any hardware process. For example, people are arguing that if you are just making model by the model itself for some auxiliary purposes and not as part of the implementation itself, then it's not worth doing. Well, we succeeded basically quite well with that experiment, but UML as a whole was not accepted by the community, so we restarted basically our design flow development. So these SDL UML based methods were top down, and then we started to look for reusability more than model based design, so we started IP-XACT. Well, the IP-XACT, why we started to think of that was it was quite complex to set up these SDL and UML based design flows, and lots of different IPs available for those projects, and that's basically the same motivation for IP-XACT as well. So we have different formats, the syntax kind of issues, that we have semantics differences, and what's even the most important is that how we apply the languages and tools, so the intention, what we want to do with the tools. And with larger systems, we realized quite soon that RTL is not enough for making, experimenting, exploring the design space, so we still need some other abstraction levels than RTL. But there is no good way of except this UML thing, but UML is not accepted, so we should have something else to capture models at RTL and DLL level or any other level. And what's actually that's quite strong message from the companies that people are designing for deadline and not for reuse, so that later when they want to come back to the old design, then nobody knows, there's no specification, no comments, and it's difficult to reuse. And the software development should start parallel to the hardware development. So, talking about HDL, the way how we are constructing the projects, I think we are mixing three aspects there. The first, content itself. So we have the structure, the behavior, if you consider that as a static thing, and then a dynamic thing is how we are creating structures using parameters and generics and functions. That's the dynamic part, and then the self-evident thing of virtual libraries, so that you have lots of name-based references and path references. And as a design flow, you get fixed the values for parameters quite late, and if you make some mistake earlier, then it can be quite difficult to trace back where was the problem coming from. Okay, so the example is this OMAP that I was surprised they put it public, and it was quite boring to read it through, so it's lots of tables of address specifications and so on. But if you think you should make an VHDL or Verilog project based on this document, then no way. Yeah, just right. Okay, so what's the IP-XACT story? It was started by two big companies. Philips, NXP had some activities on IP assembly, and then Mentor Graphics as the big EDA vendor, and they bridged together their ideas. Actually, Philips was pressing Mentor Graphics to publish their custom format for IP exchange. And now you can think that this might not be the best starting point for some open community, two big players, and later, actually it has been the playground for big companies this far. It might be that Kactus2 has been disturbing a bit of this kind of thing. So what is IP-XACT itself? So which attempts to be a standardized model for the IP blocks, the SOC designs, and also standardizing the way how they are integrated, assembled, and they have also specifications for the tool interfaces. Technically, it includes the newest version of the standard. It includes 24 XSD files and some 800 elements, 250 attributes on them. And what makes things even more complex is that the vendors can, and they do, add their own extensions. For example, Xilinx has their library based on IP-XACT, and they have added at least 200 elements, and that makes it incompatible in a way that if you think that if we have the same IP blocks for Altera and for Xilinx, the vendor extensions make it very difficult to exchange them freely. So it happens to be a methodology, not just an exchange file format. We have seen many of them. So while we are actually playing in this playground for the big header vendors and proposing Kactus2 kind of open source tool, and what can be a bit surprising is that the need was not coming from ASIC and FPGA projects, but SME companies developing embedded systems. And we first applied IP-XACT for printed circuit board level design issues, and later then we came back to FPGA and ASIC designs. And another one, which is in the last, let's say, last 2 years, has been very a good motivation for that kind of project, is that the big companies can afford those commercial IP-XACT tools, but their subcontractors not. So they need something open, at least free tool, to packetize their IPs so that it's compatible to the integrator company design flows. Well, tool-wise, we identified that the users might not be IP-XACT experts, so we tried to hide as much as possible of the complexity of IP-XACT XML structures. And in general, I was really frustrated for our previous tools where the installing of the toolset for a new user, a new computer, took half a day compiling all the stuff together. And so I decided that every tool we create from this point on must be immediately installable to any computer you just bring in. So, and it must be much better usable, because the audience is not necessarily the experts who are developing the tools by themselves. And we have followed the rule that we keep it stable, even if it's lacking some critical and very important features. So that's the decision for the tool itself. So what's the scope of IP-XACT? It actually doesn't differ that much from what we already have for an HDL-based design flow. We heavily dependent on component libraries, and we have scripts for generating, instantiating the components from the library, creating the interconnections between them, and we have scripts for controlling the synthesis. Basically, IP-XACT affects all of these. The core is the component library and the hardware design that are formalized in IP-XACT, but then it doesn't tell how you should construct the scripts for generators or synthesis scripts. So basically you can add whatever kind of language is, and that's just a placeholder for that. So it's not a language itself. I don't know how well you already know about IP-XACT, but I prepared some very basic ideas. So what is this IP-XACT? So it's an XML description of the objects it defines, and the IP-XACT component is the placeholder for especially the interface. So if you make an analogy for VHDL, it's the entity part. But in addition to that, it also defines parameters, and we have two kinds of them. One for general use of independent of how that IP block will be implemented, and then implementation specific parameters. And then we have register definitions. That has been one of the major motivation behind IP-XACT. That's for the programmers basically. And then it has in a little bit limited form also some information for non-functional properties like clock and timing issues. And then the actual behavior, if we take the analogy from VHDL, is the VHDL architecture part. And that's what is included as views, and each view can have file sets. So the source codes are still needed, but that's basically only for the behavior part, the documentation, and whatever else you would like to put it in. So it's an umbrella of information. So we have an IP-XACT design. That's the normal way of instantiating the components. And now the references are no longer based on names or paths, but IP-XACT references. And that wants to break the physical path dependencies. So it doesn't matter in what location the IP-XACT XML files themselves are located on the disk. The references are made on the IP-XACT referencing system. So we instantiate the components on the designs, and we have formalized bus definitions so that we can plug and play and make checks that the connection is fine. And for the parameters, every IP-XACT component should have parameters as to the default values, and we can override them on the IP-XACT design. But then what is surprising for HDL designers is that passing the parameters down to hierarchies is basically prohibited, but there are some ways of go around that. But still we have to be careful that every component is reusable as such, independent of the context, independent of the layer of hierarchy where it has been instantiated. So the design flow goes like that. We first have the IP-XACT components, we assemble them in an IP-XACT design, we perform there all the configurations, and then what we get is top level HDL codes, and then the behavioral part we get the code included for the synthesis, and then at the same time we get support for hardware dependent software development. And what is difficult to basically to accept is that you should do all that configuration at IP-XACT level. So the code that you are generating out from that is more or less stupid. You don't have any longer parameters and generics, but just values fixed, and of course you can have some comments where that value is coming from, what was the original IP-XACT parameter, where it was coming from. So when you need to make some tricks for the generated code, you know what was coming from what element on the IP-XACT component. So Kactus2 is covering gradually most of the picture here. We started from the IP-XACT component editors and design editors. We added configurations, and we added generators, and the latest were the import wizards, so that we can import legacy code to Kactus2. So before the demo, some challenges about IP-XACT. One is that even if it's a standardized way of modeling the IP blocks and designs, there are still many open questions like the abstraction. So if I make an AMBA bus definition, and another guy is doing the same, so there's no means of guaranteeing that we are talking about the same thing. So there should be done something. There should be some authority or some good example that everyone is using. So the vendor extensions, as I mentioned, that's a problem. It gives you flexibility, but it complicates the interoperability. And then a general note about the generation of code. So in an ideal case, you do it once, but in real life you have to make some modifications manually after it's generated, and then you should do the regeneration later, and you should not lose what you are editing. So you should have some kind of feedback the IP-XACT model from the generated HDL code level. Then some common mistakes for the IP-XACT beginners is that they try to edit manually the XML files, and what is very difficult from the tool developer point of view is that people add some comments in random places of the XML file, so it's impossible to parse them to the tool. And another one is the mindset of creating HDL designs, or actually you cannot see any benefit of IP-XACT. Why you should use as an extra modeling step for some IP-XACT modeling if you in practice want to keep the style you have done before. Okay, note about the parameter misuse or abuses that don't use that's a file reference or making some version control. So that's really abusing of IP-XACT. All right, yes, it's now your.
Just a minute to set up
Only the display, not the tool.
Yeah, do you mind if I ask a question quickly?
Sure.
Can you configure the sort of version of the block that you're instantiating? So can you say, can you have a block and then you say this version is for like small design, this version is for big design, port list changes, registers change? That's possible with IP-XACT?
Yeah, there's the references have the previous. Because you should have the file level versioning as well. So you have to decide when you are increasing the version or changing the version.
Sure, but the configuration of the block is really what I meant. So there's versioning and there's like configuration. So this may have.
Well, as long as your interface is not changing, then it's up to you basically what kind of internal changes you do there. But if you change the interface, then you should change the version.
Can you, but my question is, can you have different versions of the interface, say on the
Sure, sure, right.
Depending on the configuration you choose.
Sure.
Okay, cool.
Right.
That sounds handy.
Alright, I hope you can everybody hear me. So, just a quick demonstration on some of the possibilities on Kactus2. So, here on the left we have the library, and I will start by showing you the component which is, I would say, the most important part of IP-XACT. So, I will start by opening. This is somewhat simplistic component, but illustrative purpose here. So, first of all, we have the general information about the component. Here's the VLNV reference for this component, so you can see it on one look. So this is what you would use to refer to this specific component. Then we have added some attributes for categorizing and tagging this component and what is it useful for. Then you can add descriptions and other things for documenting what is this component for and how should you use it. And if I go down the set of elements within the component, I will start with the parameters. So this would be the things you use to configure this particular component. So usually we use, in the interface, we use yellow color for mandatory fields and white is for optional. And these come, of course, from the IP-XACT. So this would be, in this case, these parameters are used for configuring the memory of this component.
Question?
Yes?
Why does it split up some address spaces?
Now I will go to address spaces now. So this I should answer your question in a minute. So you can define address spaces for a component. It's basically what this component is. This is a CPU. What memory does it see? What is it useful for? What can it use? So in this case, we have some example segments of memory that's visible to the CPU. And Ulo, for your question, that parameters are here used for setting where exactly do these blocks of memory reside in the memory hierarchy. Now in this case, it's we wanted to have a component where you can configure that. Of course, you can set it here if you know it's always in these addresses. So the question is, can you use a parameter to set the value of another parameter, right? Yes, of course, yes, you can do that. You can refer other parameters in the values. Views you already covered. And in this case, the interesting view here is the hierarchical view that describes the submodules of this component, how this component is composed of other components. If we go down to ports, these are the ports you would see in the VHDL entity description or Verilog module ports. They would all be listed here. And when connecting this component to another components, we use bus interfaces to group ports. Usually, of course, there are connections where you connect one port from a component to another. But usually, you need group of ports and group of signals so you can wire the components together to create a bus. So bus interfaces group up the ports in this component. All right. I could show you the. So now what I have opened is the design of that previous component, and this is the internal structure of that. So in this case, we have very simple design for other components that compose the previous component. And here you can actually see the bus interfaces and the bus connections between them. So when you start from scratch, you would create a new component, and then you would start filling all the required sections, what you think you would need in that component, going one by one, usually starting with parameters, ports, views, bus interfaces. But often the case is that you already have the implementation in HDL language, such as Verilog or VHDL. So what we have been working on is the import. So here I have a skeleton component that has currently only views, and then I have already configured some files associated with this component, so we can import the port and, in this case, generic descriptions into this component. So I will run the import. So the resolution isn't cooperating. Sorry for that. Nope.
Hold down.
Working. Oh, there we go. There you go. Oh. Here. Sorry? Yeah. So let me move that. Okay. There we go. So now I will choose the file to import, and it has to be associated with the component already. So that's something I did earlier. So I will choose the file. And here you can see the file. It will color all the generics it found in blue and all the ports in green. And everything, comments and everything else will be left in black. So you can verify here that yes, you got everything you wanted from that file. And then you will see the equivalent descriptions in IP-XACT.
When you write the front-end file the information out, how you extract the information?
We have plugins for Kactus for different languages. So here you can see there are many ports. What it can't do is group them into bus interfaces. That would be nice, but it's more complicated than parsing single ports. And now you can see the imported descriptions can be found now in the sections. So give me a minute to go back to presentation. Alright, so that was really a quick demonstration, but I think we are already running out of time. So a couple of words on the Kactus2 project. We are already approaching 250,000 lines of code. And most of that is in C++. We are heavily using the Qt libraries in the implementation. And we have made the decision to run on both Windows and Linux. We actually did a test on Android. It worked, but it's not as usable as the desktop versions. So we have been driven mostly by requirements coming from both teaching and our collaborative companies that help us define what they need and what requirements they have for their design flow. And we started with the components, their editors, the design, the very core of IP-XACT. And from that we have been expanding towards registers, parts of the memory, now the import from different languages. I think generation for documentation and VHDL, they were some of the very first features to be implemented, and just I think a year ago we started expanding to Verilog. Now we are moving to parameters and configuring the components and the designs, and that's still somewhat under construction, but most of it is already there. After this, we will probably proceed to memory design, and we are also already thinking about how would the design work in 3D. So that's some of the future aspects we're really looking into.
Yeah, but the next release will be very big change upgrade to the new standard version.
Yes, so far we have been using the 2009 version of the IP-XACT standard, and now we're moving to the latest 2014.
So it will be out at the end of this month.
Alright, so that's what we have been doing. We have plenty of work done for the core. We have the working plugin interface and currently 14 different plugins for different purposes, for generation and import mostly. But now, where we would love to have some help from the community is finding the best practices, finding good examples, relevant examples. The example I run here for you guys is very simple, a very unfinished component. So what we would really need is these relevant big designs and working systems that we could use to find the best practices and examples for others using IP-XACT. Since they do not exist, even the big vendors, of course they don't want to disclose their designs and what they're using. But this is something we would want to bring to the public.
So one proposal is that if you have some project that you would like to apply IP-XACT, we could make a couple of days coding camp and just put it together. So remotely helping you might be very difficult. So it would be nice to collaborate with you and implement your design. Yeah, basically, that's our presentation.
Thank you. We have time for 1 or 2 questions. Yeah, there's coffee outside though, so we should probably be sharpish.
It's quite a nice presentation, but I just needed a couple of questions here. What about the support for Xilinx? You talked in a few slides about Kactus2 and Kactus and all that, but what about Xilinx?
Yes, we actually made an experiment just importing Xilinx library to Kactus, and yes, it goes in, but because our tool can't understand any of their vendor extensions, so it's just we can't edit it. So we can open and just write back, but not edit.
Is it possible to like import the design into Xilinx and then integrate with their IPs, or that's not sorry?
Yeah, so the question was that can we use Kactus2 to make Xilinx designs?
Yes. Import into Xilinx, make it a Kactus2 exact IP and then import into Xilinx and connect with their IPs directly.
Yeah, as far as the end result is just generating ASCII code, as far as that is possible, then we can do it.
And a small point, how about, you told me about the XI bus and the single ports which come out in the design. Is it possible to like group them into, say, an AXI name and then use it as a bus interface?
Yeah, there's a set of physical ports, and that's something firm, but the bus interfaces are more abstract, so you can freely group as many physical ports as you like, the bus interfaces, and they can be overlapping and they can be sparsely used or whatever you like. Thank you.
Yeah, I just want to say that I have an OpenRISC SOC design based on Kactus2, or designed with Kactus2. It's not the best practice yet, but if you want to take a look at how what it looks like, just come to me and I'll show you. Also, FuSOC will contain IP-XACT support too.
A really quick question. You guys members of the Accelerator Committee for IP-XACT?
No, actually, as a university we cannot join, and as an individual cannot afford.
So we have no way of sort of fixing the standard problems. Is there a problem with the standard itself? So how can we feed that back into the standards process?
No, actually we are not involved in that directly by ourselves, but the companies we are collaborating with, they then can influence if they can.
So can we give ideas to you and you can give them to the company and they can read it?
I can't promise anything.
Any more questions?
Yep. Actually, I have 2 questions. Of course. I'll tell you before. The first one is, last time I checked, the the interconnect code generated by Kactus2 is only VHDL, not Verilog, but you had some statements on the website saying it would be possible to add Verilog. What's the status on that?
We have Verilog generator finished.
Awesome. The second question is, do you support the IP-XACT component generator tag in... No, okay.
We can read it and we can write it back, but you can't edit it yet.
Okay. Do you want to answer, Rob? Alright, thank you very much, guys.